So our next topic is iterative statements. So basically, those are just a statement or collection of statements that you want to repeat multiple times. So it typically involves the body of the loop, and then either some sort of pre-test or post-test that you use to determine whether the loop should be repeated or not. So we're going to look right now at counter-controlled loops. So loops that are counter-controlled typically have a loop variable, and some of the questions or concerns associated with counter-controlled loops are how are the initial or terminal values determined? Do you allow a step size other than one? What is the type and scope of the loop variable? And can the loop variable change inside the body of the loop or not? And should the loop parameters be evaluated at every iteration? So we're used to the for statement in C-based languages where you have the for and then the expression, semicolon, expression, semicolon, expression, and the loop body. The loop body can be a single statement, or it can be multiple statements, or sometimes it can be empty. That is, all the work is actually being done in the for statement itself. If we think about the way the loop executes, we think about sort of pseudo assembly code for it. Expression 1 happens first, and then if expression 2 is equal to 0, that is if it's the end of the loop or it's false, we're going to skip over the body of the loop. Otherwise, we're going to execute the body of the loop, execute the update or expression 3, and then go back up to the top of the loop. So all of the expressions in the for statement for C are optional, although if expression 2 is missing, it's assumed to be true. Often we use these obviously for counting, where we initialize a loop counter, test it, and increment it, which is what we're used to most commonly with for loops. For loops in C-based languages can get quite complicated. You're allowed to have multiple initializations. So in this case, we're initializing I and val. You're allowed to have a complex condition to terminate the loop, and in this case, we're checking the value of I and val. And then you can do multiple things in the update as well. So this particular statement is incrementing I, and reassigning sum and reassigning val as well. So this is just an example of the sorts of things that you could do in the for loop itself. And notice the body of the loop is empty. All the work essentially is getting done in the for expression. This allows for flexibility, but it's not terribly readable, obviously. And then this is just the semantics of what's happening in the loop. In C++, Java, and C#, so more modern languages, we can both initialize and declare the loop variable in the for statement, in the first expression. And then typically its scope is only the body of the loop. That is, it's not accessible after the loop terminates. In both Java and C#, these statements are almost identical, except that in Java, the second statement is restricted to be a Boolean type, whereas in, for example, C or C++, it could be an integer type. In all of these languages, the loop parameter, the test, and the update, expression 3, are evaluated every iteration of the loop. And the loop variable can change in the body of the loop. So inside the loop, you could say I equals 7 if you want to. The for statement in Python generally looks like this. You have for some loop variable in an object, and the object is often a list, for example. The for loop can have an else clause, which is executed if the loop terminates normally. So it would be at the end of the last iteration of the loop. And the sort of objects that we might loop over include lists. So this second example here was A is equal to 246. We can say for I in A, and that just assigns I to 2 and to 4 and to 6. We also can use the range variable to do a range operation to do a sort of counting loop where I is in the range 0 through 4 by using this range of 5.